Hey everybody, welcome back to another YouTube tutorial. My name is Insert Name here, and today we'll be taking a look at part 2 of our car AI tutorial series. We'll be using enums, triggers, and line tracers to create a more advanced AI that should be able to corner about everything we give at it. So without further ado, let's get into the video. Now let's go over everything we did in part 1. We made an AI car that's capable of following the spline we defined, but not very well. We also have not coded any braking function yet, so let's fix that right now. We'll start by creating an enum. This enum will store the type of corner we are at, for example a hairpin. You can create a new enum by right-clicking in your content browser, going to Blueprints, and then Enumerator. We will name this enum e_turn_index. Now open the enum. We will start by adding a new index. The first corner we made was a sharp right, so let's create an index for that. We'll be using this enum later in the video, so we can just save and compile that. Now that we're done with the enumeration file, we can just go to our AI Clara blueprint. We are going to create a new macro called speed limiter. What this does, it will limit the car's speed around the corners. Now the reason we're creating a macro above a function is because we want multiple execution pins. So let's just create a new macro, call it speed limiter. Now just move the outputs node a bit further out. Then by holding B on your keyboard and left clicking you can make a new branch node. Helpful tip. You can take the beginning execution pin and just drag it to input and drag the true and false execution pins to the output. Now you can just take this condition struct pin and drag it to a less node. Then you can take your get current car speed function and drag the speed into the top struct pin. And then you can take the bottom struct pin and drag it into the input. You can call this speed limit and call the output execution pins under speed limit and over speed limit. I can just compile and save that. You can go back to your event graph. Now we're also going to create another function. This function will apply the throttle and brake input. And the reason why we're creating the function is because we're going to use this code quite a lot and we want to keep our code clean. So name this function set input. Now it's important to note this will not set the steering input, it will only set the throttle and braking input. That's because we're only going to set the steering input once every tick. So we're just going to create a new node. This will be our set throttle input. And then we'll drag that execution pin in. And then we'll also create a set brake input. Now we'll also drag the throttle to the input and then the brake to the input. That's so everything that calls this function can set the throttle and brake on their own. Now you can just compile and save. Now we can just go back to our event graph. Now bear with me, we're actually gonna make another function, but before we can make that function, we should go to our viewport. We'll add a new component. This component will be of type scene. And what the scene component will do is this will be the start point of our line trace. So you can name it line trace start point. Now that we did that, we should also move it in front of the car. You don't have to be too precise with this, it should just be at the front of the car. Then you can compile and save. Then we can go back to our event graph and create the new function. This function will be line tracer. We can of course rename it later on if we find a better name for it. Now you can just go to this line tracer and then you can add a line trace by channel node and then plug in the execution pin. Now to get the line trace end and start point we're going to do a bit of math. I'll explain a bit of it as we go with it. And let's start with the start point. You'll get that by taking the line trace start point, then getting world location, and then you'll plug that into the start node. But how are we gonna get the front line trace? How are we gonna get the endpoint? Well, you take the line trace start point and get the forward vector, which means the front of the line trace. And then we multiply this with a certain value. This will be how far the ray shoots out. It's fully customizable, but I'm decided on a value of 1500 because that's what I found worked pretty well. And to actually make this the endpoint, we're gonna have to take this get world location and add it to this multiplication. And then you could just drag that into the end. Now that is all the math we got to need to make a line trace. Now we should actually store this out here and return value in variables. So we can just take this out here and promote to variable. This will be our front line trace hit result. And then we'll also take this return value and also promote to a variable. We'll name this. We'll name this front line trace hit. You can make a question mark there, and this will check if we actually hit something with our line trace. You can compile and save and go back to the event graph. Now when you're in your event graph, you'll just take the set throttle input and delete it. We're not going to use it currently. Then you're going to take your speed limiter, plug that into the set steering input. And this will be the speed the car minimum, like the minimum speed the car needs to go. If it's under the speed, it will always throttle. It will never go slower than this speed. We'll write more advanced code later on in the series probably, but this is just gonna work for now. Now I think 10 works really well. The car shouldn't ever go slower than 10. There's no reason for it to go. So if it's under the speed limit, we can just take our set input, plug that in under speed limit, and that means we should always throttle, no matter what. If we're over the speed limit, we're gonna do some more code. We should set out a line trace when we are over the speed limit. This will make sure that we're in a corner or not in a corner. And after we've done this line trace, we should check if our front line trace hit. If it did, then we'll just make a branch node. Remember, B left click to make a branch node. Just connect your line tracer, connect the front line trace here. And if it hits something, then we'll check if it's in a corner. But if it hasn't hit anything, it's safe to assume it's in a straight. So we're just gonna make him throttle fully. So you just get your set input and then make the throttle 1. Because it's, like I said, if the trace doesn't hit anything, it's safe to assume it's in a straight. Now before we can check if the car's in a corner, we're going to have to make a new blueprint actor. So go to your content browser. Right click, blueprint class. This will be of type actor, and this will be our corner index. Now you can just open that up, and you should add a component to this. This will be trigger. This will be a box collision. Yeah. Now this will be by default a trigger. So, but we'll just call it trigger for more clarity. Now I also have to add a variable, and this variable will be of type that we defined in our enum. So it will be e underscore turn index. Now you just make that a object reference, and we can just name this turn index. Yeah, and then you can just compile and save that. Oh yeah, and also important to make this public. and compile and save so we can change it in play mode or in the editor. Then you should go back to your AI car. Now we should make a new macro. This macro will check if we're in a corner currently. We'll just make this macro, we'll call it get corner. The reason it's going to be a macro is because we're going to require multiple execution pins again. Now we're just going to get overlapping actors. And the class filter will be the actor we created, which is corner index. Now this will get the overlapping actors. It will get multiple. So we're just going to use a get a copy to just get one of them. And then we're also going to use a is overlapping actor. We're going to use the mesh for this one. If this is overlapping this actor, then we'll just do a branch node. B, left click. And we'll connect this execution pin to the input. And we'll also make these outputs. We'll just connect true and false to the output. And then we'll connect this to the overlapping actor. Now, if this is true, then that means we are in a corner and we want to know more about the corner. So we'll actually connect this get and put this in the output. And let's rename these. This is in corner. The second one is not in corner. And the bottom one is the corner itself. We'll use that to get more information about the corner. Just clean up the code a bit here. I might bring out a dedicated video just to actually cleaning up our code and making it look prettier by using maybe more macros or just cleaning up by adding comments, but that would be in the future. Now that we're done with this macro, we can go back to the event graph. And here at this front line trace hit, we can just drag in our get corner macro, plug in the execution pin. Now, if we're not in a corner, we should use our line trace to detect how much we should break. So we'll get our set input, yeah, and then we'll plug in not in corner into the set input. And this break value will be worked out by using our line trace information. So we'll take our front line trace hit result, use a getter, then right click this, right click there, so we can split the struct pin. Yeah, I'll just wait for Unreal to work. Awesome. Now we're going to take this front line trace hit result distance, and we're going to plug this in a map range clamped. This means it will break more or less depending on how close it is to a wall. We'll plug this return value into the break. And this should be 0 to 1, the in range A and B. And out range A and B should be 0, but B should be the range of your line tracer. Because we did it already, we made it 1500. I'm going to make it 1500 here. So how close it is to wall, it's going to break more. And that's about it for this code. That means if there is no corner, it's just going to break because it doesn't want to crash. But if it breaks more, then the current slower speed that we coded here at the speed limiter, it will again throttle because it doesn't want to go slower than 10 kilometers per hour. Now we'll take this get corner and make a cast to corner index node. Then take our corner and make that the object reference. And we'll use this as corner index to get the enum we created, which was turn index. Get turn index, awesome. We'll take this turn index and create a switch node from it. If you don't know what a switch node is, it's kind of like a branch node where based on what enum value this is, it will run different code. We'll take this cast to corner index, drag the top pin, make sure it's the top pin. If the cast fails, we don't want to do anything. Now when we're going to be here with our switch node, we'll take our sharp right and use our speed limiter and plug that in to the sharp right. Now you can use any value here. For sharp right, I found that 20 works really well, in my case. When we're under the speed limit, we'll just take our set input, plug that in. If we're under the speed limit, we probably want to throttle. So put that to 1. But you can use Control-W. We're going to create another set input. If we're over the speed limit, we'll probably want to brake, since we want to stay constantly at that speed. So brake 1. And you can do this for any enum value you have. If you add a new corner like a hairpin, you can just drag more speed limiters off and set input based on the speed limit. And you can just compile and save that. Now, before we can actually go test this, we should go to our vehicle movement component. And we should look for our KD setting. It's reverse as brake, yeah, under vehicle setup, it's reverse as brake. We want to disable that because we don't want the car to reverse if he's braking at 1 when he's going around the corners. So you can just compile and save. Also, before we go test this, we can take our line tracer, open that up, that function, and then this draw debug type. We'll just make this for 1 frame. Compile and save. If you're done testing, you can just put this back to none. Now we can go back to our vehicle advanced example map. Now we'll just make our car go around this corner. You can set up other corners if you'd like. It's the same principle. You're going to take the corner index, drag that in. Then you're going to scale it up to fit your corner. This was the trigger I was talking about. This actually limits the car's speed around the corner. It doesn't have to be too precise, just something you feel comfortable with. Now, when this is done, we should also create walls for the corner. This will be used for the line trace to detect how much it should brake. So don't worry, we'll make these invisible and also have no collision in the future. So don't worry, you can just drag this out. And you can hold Alt down to make a duplicate. Like I said, doesn't have to be too precise. But make sure that you have some on the inner and outer corner. Because sometimes the car will turn in like this. And if it doesn't have a wall there, it's going to go too fast and go off the track. So make sure you cover up every single part of the corner. Just rotate here. Something like this should be... Actually, wait, no, let's just fix that there. Something like this should be good there. I think we'll just add another one here to be safe. Add another one here to be safe. Yeah, something like that should work pretty well. So if I hit play now, you'll see the car goes, and it will use this wall as a brake. Then it'll turn here, match its speed, and go along the line we defined. Now you can do each part of the track the same way we did this part, but I'll also explain to you how to set up new corners. So what you do is you go to your E-turn index, and we'll add a new corner type. Let's, for example, call this a hairpin. Now you can save that. Now when you go back to your AI car, and you go back to the event graph, you'll see a new hairpin on the switch on E-turn index. Now you can just copy this code again by using Alt-W. Oh, no, you'll have to use Control Copy and Control Paste. Now you'll take this hairpin, put that into the speed limiter, and you'll now have to set up a speed limit that you feel is comfortable. I haven't played around with the hairpins, but I think something like 12 should feel pretty natural around hairpins. Of course, you can play around with this value, like I said. Compile, save, and when you go back to your vehicle advanced map, once you drag in the new corner, you just take your corner index, and then you scale it up to fit the corner you're creating for. Like I said, doesn't have to be too precise, only something you're comfortable with. And then here at the editor, you go to this default turn index, and now you can select what corner this is defined as. If this is defined at a hairpin, it will run the 12 or the speed we defined in the speed limiter here, but this one will still be 20 kilometers per hour. And this way you can set up multiple speed limits around your track based on your car, based on your path. Also note you should put corner walls around every single corner, also a bit on the outskirts. Like I said, a car can turn into the wall, and if there isn't a wall there, then it isn't going to know it should brake to make sure it stays in the track limit. So you can just delete all the bumps, the ramps, everything, and just make a new track and follow this simple principle, and then you should have a basic car AI that can go around your track. In future episodes, we'll probably clean up this code to use a component, and we'll also fix the fact that the car is, when he's at a corner, he's braking and driving and braking and driving. That might not work for certain car configurations. We'll just have to find a new way to put a speed limiter in the Chaos Vehicle blueprint. Hey everybody, thanks for watching. If you liked the video, hit like. If you didn't, hit dislike. Please consider subscribing. It really helps out the channel. I also like to point out that one of the Unreal YouTubers I'm subscribed to, Reids Channel, has currently released a beta for Samurai Zero, a game that he's been really passionate about for a couple of years. I've learned a lot from this YouTuber about Unreal Engine, so I'd really appreciate it if you can support this YouTuber. I'll link his channel down below. Maybe go play the new beta he's currently running for the weekend. Anyway, like I said, thanks for watching. Good night, everybody.